Hi folks, we're going to take a look at 6b from the test 3 preparation sheet. And again, we have a system of 3 equations and 3 unknowns. So as usual, first step, I'm going to label my equations. Okay. And now, of course, what we do is we try to eliminate the same variable twice. So I take a pair of equations and I have to eliminate one of the variables and then repeat for a different pair. Okay, so here, I guess let's work with 2 and 3 and maybe 2 and 1, since 2 and 3 are pretty easy. We have a -2 on both of the y's, so let's start with that. So we've got equation 2. We don't really have to manipulate either one of them. So 3x minus 2y minus 3z equals 10, and then equation 3 we have 10x minus 2y minus 7z equals 33, and since the signs are the same, we should be subtracting these equations. So 3 minus 10x, so we have -7x, -2 plus 2, that disappears, and here we have -3 plus 7, so here we have plus 4z equals 10 minus 33, which is -23. Okay, so here we have what we're going to call equation 4. That's what we're going to use to solve our system of 2 equations, because now, well, let's keep that up there. We need to take another set of equations to eliminate y in another pair. So here I'll take 1 and 2 if I can avoid working with that 33 there. So looks like I'll have to multiply equation 2 by 2. So 2 times equation 2 gives us 6x minus 4y minus 6z equals 20. Okay, and then we'll take equation 1 as is. We have x plus 4y plus 2z equals 1. And so now we'll be able to eliminate the y's. Okay, so let's do that here. Since the signs are opposite, we can add the 2 equations. And when we add this, we have 6x plus x. We have 7x. The y's cancel out. We have a -6 plus 2, so minus 4z equals here 20 plus 1, 21. Okay, and now if we'll call this equation 5, since we've created a new equation, and now we're going to use these 2 equations and 2 unknowns to solve for x and z. And here, if I notice 7x, -7x, I don't actually have to manipulate either of the equations, because this will just be -7x plus 4z. Noticing here something a little interesting. Okay, and I keep in mind that there's more than just the possibility of there being one solution for these systems of equations. So here, -23. And when I add these 2 equations, which I'll do because these signs are opposite here, I end up with 0, okay, plus 0 equals, well, 21 minus 23 is -2, so I end up with 0 equals -2. And that's a contradiction because 0 is never equal to -2. So the conclusion that we can make from this is that there cannot be any solutions to this system of equations, because when we solve it using our operations, which we can use to solve a system of equations, it leads us to this contradiction. So we can say here that therefore there are no solutions to this system. Okay, and let's recall if we had come up to, after having worked with all 3 equations, something that was -2 equals -2, or 0 equals 0, which is always true, then the conclusion that we can make from there is that there's infinitely many solutions. And of course, the last possibility is that there's a unique solution for x, y, and z. Okay, that's it for now.